This video is on mass, volume, and density. So now that we know how to take proper measurements, let's talk about some of the measurements that we are going to be taking in this class. So mass. Mass is a measure of the amount of matter. How much stuff is there? And this is going to be measured on an electronic scale in grams. So you need to go ahead and associate grams with mass. Now, how mass relates is different than weight. Weight is the effect of gravity on a piece of matter, and the mass is just how much matter there is. It doesn't take gravity into account. Now, volume, we talked about measuring volume of liquids yesterday in the graduated cylinders. If we wanted to find the volume of a regularly shaped object, we would do that by length times width times height. You know this from math class, and this is just how we figure out how much space something takes up. So if I have here this box, it's length times width times height, and all dimension measurements must have the same units. So you can't measure the width in centimeters, the length in meters, and then the height in millimeters and expect to multiply those together. All your units have to jive. Now, units for volume. Volume, again, if we're talking about a solid or a regularly shaped object, it would be measured with a ruler, a metric ruler. And if all dimensions are measured in centimeters, it would be centimeter times centimeter times centimeter for length times width times height, and you would get centimeters cubed. So that becomes a very appropriate unit for volume. If you measure the volume of liquids in a graduated cylinder, you're going to have units of milliliters. So that is also an appropriate unit for volume. And you need to go ahead and associate these because in a math problem where you're going to have to apply these, they may not say the volume of this object is. It'll just say, hey, it was 50 milliliters of this liquid. And you're like, oh, milliliters, that's volume. Now, if we look at how milliliters and centimeters cubed are related, a milliliter is a centimeters cubed. It is also a cc. Cc is what they use in the hospital or medical field, and it just stands for cubic centimeter, which is a centimeter cubed. They don't usually like to have superscripts and things like that just because of the messy handwriting. All right, so we can have volume in centimeters cubed or in milliliters, usually centimeters cubed for solids and milliliters for liquids. Now, if we don't have a regularly shaped object, how are we going to find the volume of that object? Well, we are going to use water displacement. And so a solid displaces a matching volume of water when it is placed in a container. So we have a graduated cylinder large enough to hold our object. We're going to put some water in there and about half full, or as long as we have enough to cover the object. And I'm going to take an exact measurement. So put it on the table, get eye level, read the bottom of the meniscus. And in this case, I got 25.0 milliliters. Then I'm going to add my object carefully so that none of the water splashes out. And what I end up getting there is the water level will rise as the object is added. And I would take a new reading of the water level. And in this case, it was 33.0 milliliters, and that's the water and the object. So to get the volume of the object, I just need to subtract these two volumes. And so 33 minus 25 gives me 8.0 milliliters. And so that is the volume of that irregularly shaped object. Okay, so mass and volume are related to each other through a substance density. So density is an important and useful physical property. We can use it for identification purposes. When we find the density of a material, it is something that goes unchanged. It compares how massive an object is with how much space it takes up. You may have been fooled by density before, where you picked up an object and it was heavier than you thought it was going to be. You were fooled by density. Or if you've picked up an object and it was lighter than you thought it would be, again, you've been fooled by density. So again, it is comparing how massive an object is with the amount of space it takes up. So I have three different substances here. The first one is mercury. It's a very, very dense liquid at room temperature, 13.6 grams per centimeter cubed. It's more dense than lead is as a solid. So particles are really, really close together. Platinum has a density of 21.5 grams per centimeter cubed. Again, even more dense. Platinum is a very, if you were to hold the same amount of platinum and the same amount of mercury, the platinum would feel a whole lot heavier. Aluminum, though, has a very low density, and you've had experience with like aluminum foil. It has a density of 2.7 grams per centimeter cubed, so much less dense. Okay, so when we're working with the density formula, it is mass over volume. A lot of times we will abbreviate that to D equals M over V, just so we can have a nice little formula to work with. Mass is measured in grams, and volume is either measured in centimeters cubed or milliliters, depending on whether it's a solid or a liquid. So the units for density are grams per centimeter cubed or grams per milliliter. And that milliliter and centimeter cubed for the same substance are interchangeable. Now, some helpful hints when you're working with density problems. Rearrange the equation first before you plug in the measurements. So the way we would do that, you can just do it algebraically, or you can use the triangle trick. And the way the triangle trick works is you got to have the triangle drawn correctly. And this one, most students can remember. DMV is the way that one goes. And if two variables are over one another, it's division. And if they're beside one another, it is multiplication. And what you're going to do is you're going to cover up the one that you are looking for. So say I want to solve for density. I would put my finger over density and look at the other variables. Mass is over volume, so density is mass over volume. I can also cover up mass and that have density beside volume. So mass is equal to density times volume. And then if I was looking for volume, I could cover up volume with my finger, and then mass would be over density. So volume is mass over density. And go ahead and write that down and then plug in your numbers and get the answer. You always want to include your units in the math problem and in the answer because, again, these are measurements and these are calculations of measurements, and the numbers mean something, and we want to make sure that we indicate that. So here I have a little problem, and this one's a pretty easy one. It is different than the one that's in your notes packet right now. So this one says that I have an object that has a mass of 42.7 grams, and even if it didn't say that this was the mass, we would know that grams is mass. And it has a volume of 9.4 centimeters cubed, and the question is, what is the density? So we've got our formula here, and this is given to you in your reference table, so you don't have to memorize it. You just have to know how to work with it. I'm looking for density, so it is just going to be mass over volume. I could also do that with the triangle there. And so now it's just going to be plug and chug. So density is mass over volume. My mass is 42.7 grams. My volume is 9.4 centimeters cubed. My units do not cancel out, so they're going to stay exactly as they are. Grams will be on top, centimeters cubed will be on the bottom, and that's appropriate for density. Then I'm going to divide. Now, when I plug this into my calculator, the calculator spits out 454,255. But I want to report my answer with the correct number of sig figs. Since we are dividing, the rule for sig figs is that with multiplying and dividing, you go with the fewest sig figs. This one has 3, this one has 2, so my answer should have 2 sig figs. So 1, 2, consult the next number. That 4 is not going to make that 5 round up, so my answer that I would want to report is 4.5 grams per centimeter cubed. All right, now let's look at another one where we have to rearrange this equation a little bit. So we have a piece of metal that has a volume of 26 centimeters cubed and a density of 1.35 grams per centimeter cubed. What is the mass of the metal? So I need to solve for mass. I use the triangle trick for this. I cover up mass. D and V are beside each other. So mass is equal to density times volume. And now I'm just going to plug these in. Density here is 1.35 grams per centimeter cubed times my volume, which is 26 centimeters cubed. Centimeters cubed cancels with centimeters cubed because one's on top, one's on the bottom, and all I'm left with are grams, and that makes sense since I'm solving for mass. Now the calculator is going to spit out 35.1, and I need to figure out my sig figs. So we're multiplying, so we go with the fewest sig figs. I've got 3 here, 2 here, so my answer needs to have 2. 1, 2, consult the next number. The 1's not going to make the 5 round up, so my answer would be 35 grams. So very easy, simple calculations that we can work with in finding density. Now you do have density on your reference tables. And that way, what can happen there in a problem like this, where we solve for density, instead of asking for what the density is, they could ask you what is the material. And what you would do is you would use your reference tables, and at the bottom there, we've got a lot of different metals. And so you could look here and try and find a substance that has that density. Oh, there's one that has a density of 4.5 grams per centimeter cubed. And so this particular metal is titanium. All right. Let's see. Now we can get a little more advanced with these problems. Here are a couple more, and these are in the notes packet that you have. So in this particular one, it gives you the density of mercury. And I could have done that problem this way, or I could have just said, started with the second sentence, because mercury is actually on here and you have its density, which you could find because you always have access to those reference tables. And I could just ask, what is the mass of 95 milliliters of mercury in grams? Well, we have a little issue here with units, but not too bad, because remember, a milliliter is the same thing as a centimeter cubed. So while mercury has a density of 13.6 grams per centimeter cubed, that could also be expressed as 13.6 grams per milliliter. And that would be a very simple little problem. If I am looking for the mass, mass is going to be density times volume. I've got 13.6 grams per, I'm going to change that to milliliters because milliliters is the same thing as centimeters cubed, times my volume, which is measured in milliliters. That's how I know it's the volume. Milliliters now cancel out, and I would be left with grams. And so 13.6 times 95. The calculator spits out 1292. And then I have to deal with my sig figs. I have 3 sig figs here. I have 2 sig figs, and when we're multiplying, we go with the fewest number of sig figs. So it should be 2, 1, 2. Consult the next number. The 9 is going to make that 2 round up, so it's 1, 3. And then we want to put zeros until we get to the decimal, because remember, we're trying to round, not destroy the number. And so the mass of this substance, or this mercury, would be 1,300 grams. All right. The last problem that I have there is tricky, because in this is basically a 2-step problem. I give you the mass of a piece of copper, but I don't give you the volume. I make it so that you have to calculate the volume. And it's even more tricky than that, because if you look at my measurements, we've got length, we've got width, and we have our height here, but our height is in different units. You have to watch. Tricky Miss Zalewski will get you, and especially because I know that you're programmed not to look for units. So the first thing that I would want to do in solving this problem is find my volume. So that's going to be length times width times height. And so that would be 9.36 centimeters times 7.23 centimeters times, And then this one, I've got 0.95 millimeters. Oops. And I want to go to centimeters. So I'm going to have to move the decimal one place that way to get it to centimeters. So 0.095 centimeters. So when I plug that into my calculator, then I'll round it to the correct number of sig figs, which in this case would be 2, 3 sig figs, 3 sig figs, 2 sig figs. So my answer would need to be 6.4 centimeter times centimeter times centimeter is centimeter cubed. Now, that's just my volume. That has not answered the question yet. So what I need to do now is I need to calculate the density. Density is mass over volume. And so the mass that they gave me was 57.54 grams. The volume that I calculated is 6.4 centimeters cubed. No units cancel out, so my answer will be in grams per centimeter cubed. And this is going to be 57.54 divided by 6.4. And the calculator spits out 8.9906. I'm dividing, so I'll go with the fewest sig figs. This has 4, this has 2. So I need 2, 1, 2. Consult the next number. That 9 is going to make that 9 round up, which is going to make that 8 round up. So I should end up with 9.0 grams per centimeter cubed as my density for this particular piece of copper. We could also do volume calculations this way by water displacement. Same sort of scenario where we have the amount of water, and then after we add the object. So we determined earlier in this video that the volume here was 8 milliliters. And so we would just take 48 grams divided by 8 milliliters. And I think we would be right there around 6 grams per centimeter cubed.